Start recording. All right, so this has been fun. We just spent like 20 minutes dealing with Google Hangouts being just utterly useless.
Yeah, it's the first time I've ever seen that happen, actually.
Yeah,
It's been pretty solid for me.
yeah. We've had to make like 3 new Hangouts to actually get it working, and I rebooted, which seemed to be unnecessary. I don't know. Google. Okay, so the plan this week is to look at basically the sort of assignment that I set last week, well, the week before. We had a little break, which was the Pong game. So what I'm going to do is going to run it now and see what happens. Ooh.
That was like a, 2 hours, 2.5 hour time box.
Mm-hmm.
But yeah, I totally clanked it. And we were discussing the reasons why, mostly because I was going to do a very simple, like rectangle-based version, but then we were talking about Minkowski Distance, and I basically panicked on that and tried to do it, but didn't quite work out.
Mm-hmm. That's all right. So what I'm just doing now is I'm just quickly commenting out everywhere that plays sound, because I just realized, this is going to be in my ear constantly. So, whoops. Okay, so like this is the game just for people watching, and you can see already that that ball just cruised straight on through the bottom of the paddle. I thought this was quite interesting, actually. That so that's fun. That's fun. So what? So let's see. So what was I going to say about this? I've got a bunch of notes on things to talk about. So the first thing was that it's not a big deal that it's not finished. I wanted to talk about just sort of generally doing like code reworking and stuff.
Okay.
So I'm going to start with like a diagram that you've seen before, just sort of have a starting point. So, if you're like building something, it's kind of like building like a block stack. Like, you might have some blocks like this and a block like that. And, then, you can build up blocks on top of it and so on. And like what you often find is, you might build something like that ends up being like, a little block here and a little block there and a little block there and a little block there. And you then find it's like, oh, I want to stick something like that, I don't know, on top of it. And so what it's helpful to do is to take, all of this stuff and, it's like, all right, we've done that once. We know we need to end up like here. So let's take all that and just sort of take what we learned. We need to get up to there. Can we do that in like a simpler sort of boom, 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 like single block? And that means that basically we can, build our tower of blocks taller. So that's like, you've seen that diagram before.
I have no idea what you're talking about.
All right. So this is like it's like a complexity ceiling thing that I talk about often.
Right.
And
Okay.
so the idea is like the bigger and sort of more solid you can make the components of your program, the higher you can build this tower. Whereas
Okay. Yeah, I get the premise now. Okay. Mhm.
if you're like sticking together a whole lot of little bits like this, you can
Mhm.
only maybe get up to there before the whole thing collapses.
These
Um,
are also known as layers, right? Indirection and all
um,
sorts of units of work or granularity or unnecessary.
Yeah,
states.
I think of it a little more abstractly than that. Like I don't want to put like and like I absolutely wouldn't say that, oh, this layer in between these two things is like this is a class and this is a class, and they have sort of function calls. It's like all of that stuff would be like, no, 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 like none of that really applies. It's a lot more abstract than that. um,
Sure. Okay.
so a better way to think of it is just like, this is one section of the program with some responsibility, and it doesn't really matter how it's structured so much that it's sort of just a cohesive whole. um, so do, 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 do. Um, so that's sort of the important bit. And what I wanted to say is that when you get to like a point in sort of programming where you feel like you're getting stuck, say maybe you get up to here and it's like, oh, I don't know where to go from here. What it helps to do is like grab all of these things and just say, right, let's think about these. Can I like rework these, not so much refactor, but rework them so they're just like a much more solid, cohesive whole. So you don't actually get any higher in this sort of functionality stack yet, but what it does mean is that later on you will be able to get higher. And the important thing there is like, you're not specifying like rigid interfaces or anything as such. It's more of a process of simplification. So like if you have a whole lot of little fiddly bits, if you can make that into one or maybe two or something larger bits, that helps out. So the other thing as I wanted to mention is like, obviously know about Casey from Handmade Hero. He sort of has a similar process, and he calls it compression-oriented programming. And that he's got an article on it on his website, and that's gives sort of a fairly good overview, but I actually think that it's not as good of an understanding as like some of his earlier episodes of like Handmade Hero, where he goes over it.
Okay.
So I kind of like, I want to just cover that now, because I feel like that's not so much something that we're going to look at as like a specific thing to do, but more of a way of thinking about how to like approach these problems, like that sort of thing, about
Right.
how you go about doing that. So sort of I just want to bring that up now so that like we can keep it in mind, and so like later on I can like point to a thing. It's like, look, we can compress that, we can simplify this as a stage. So
Okay.
that's sort of like
I
the
think we sort of introduced it very lightly in the sense that your last exercise was, no classes and everything should
yes,
be in a single file, that kind of thing. And
yeah,
that's, I guess, to make it more compressible because we don't have to go hunting it around for the code where it lives and so on.
yes. So that's something like, yeah, I do want to like expand out on that, because there's a certain way of programming that, like, you've got object oriented programming, where you have a bunch of objects and they each do a thing, and you might have like, because we've been doing collision stuff, you might have like an object. It's like, this is the collision manager object or something, and it's like, well, it goes out and reads the world state from the world state object, and then it spits out like a bunch of collision objects like on another call. And the thing about that is it's like, well, here's a whole lot of blocks, and maybe these blocks are like off doing like other nonsense, but here's a whole bunch of blocks that we can actually just go, oh, this is all just one system, and maybe we can like reduce like the amount of state involved, the number of like function calls going in and out of this thing. We can just really simplify it, and we might look at that when we look at the code in a sec. But there's like, there's no sort of clear way to say this is not so much a process as sort of an aesthetic about how to program these things.
Right. So what's the point?
So, what's the point?
What's the point? I mean, I'm just asking for conversational purposes, but I mean, you intuitively, I think you probably reach a point when you're programming or in your programming career where you reach a point where you realize that less is more, and then you strive to reduce the amount of code that you write without, and you kind of intuitively grasp this concept of efficiency and compression and so on. But it's still, to me, like an intuitive sense. It's almost like an artful sense,
yes.
as opposed to, you can really screw yourself over with a lot of complexity, right? Because you're talking about a complexity ceiling. You will hit the ceiling, and you'll not be able to get further doing the goal you wanted to do because you can't understand the whole picture. But so I guess in that sense, it's practical.
Yeah,
but it's just maybe difficult for like somebody who's maybe not at that point.
One thing, like I can give a bit of I try and give a bit of an example. That was transparent.
Well, it's relevant because right now, like almost everything you see about making games is about how many dozen components and entities you can stack together, like and how everything has to like reusability to a dangerous level and all that. That seems to be the way right now. So it's probably relevant to understand why that might not be the way.
Okay, so there's a few things we can say about that. One thing that really just sort of personally causes me like a little bit of irking is there's I'm trying to think of the best way to put this. So so we work like we just worked on a game that's based on XNA, and XNA has like a class called like built into it called game.
Oh right, we didn't even touch those things.
Yes, with very good reason. And it's like that's a class, and it's got it's an abstract class. Oh, my handwriting, with like a draw method and an update and like a what is it, like load
content, unload content. Yeah, it's basically like the same interface as like the game class, but just out in its own blob.
Yes, and what people tend to do is they like see this like class that they can use, and they're like, oh great, well that must be how I need to do it, and so they make like, well, geez, I guess I must make my player like a thing that my player will inherit like object-oriented style from this drawable game component class, and maybe my level will as well, and blah blah blah. And the thing about this is like these have like method signatures, which is like, I can't remember, it's like they get the same information as the game thing. I think it's like game time, and this gets game time. I think this gets nothing. And it's like, the problem is you want to, like, I mean, you saw our code on River City Ransom. Like, our update method takes like a, update context.
Yeah, I think I might have typed that about 40,000 times.
Yes, which is a class that's got like, I don't know, like 20, 30 different things in it that are sort of involved in, information that you might use in an update that's sort of transient between frames. It's like, this is all of the information you need to calculate an update step for this frame, and then draw, we have a draw context, and we actually have several phases. So it's like, register to draw.
Register physics, register shadows. And
exactly. So there's like a whole lot more methods that are on, not drawable game component, but like our actor class that we've sort of built up because they're necessary. So that's one sort of thing to watch out for, is like,
right. So, sorry. I think I see what you're saying. Like, when the component is so generic, can't solve a specific purpose, you end up, there's nothing in those signatures. So where are you going to put the state you need? You're going to put it in the component, which means you're going to bloat the component up to stateful size and not realize you have a problem until you try to run the game on the network or something. And then in reality, our update context is filled up by the game engine and passed to our method. So we have all the state. It's not necessarily has to be persistent either. It's much more functional in nature, because every method gets all the information it needs to do its work. There's no ambiguity about, you don't have to go hunting for this stuff in different components to like assemble it together, and you don't have to do it in every component. Basically, this is what you need, and you get it right in the method signature. So I think is that where you're headed?
Yeah, and like, the other thing we were talking about was like reusability, and it's like, well, one game's player or level is going to be totally different to some other games like player or level. It's really hard to get reusability, and I know that's actually something we're working on in the background. But
yeah, try to actually split up the update context.
Even then, it's like, you wouldn't like, it would be really hard to make like a Mario style game on, say, the River City Ransom engine, because everything's set up for like 3D pixel based stuff, whereas if you pretty much couldn't reuse that to make a 2D game, for example.
Well, just look at the forest levels in River City Ransom Underground as an example of trying to bolt the 2D concept platformer into the game and not being super successful. I think it worked okay. It was more just the pathfinding and such was difficult. The AI pathfinding.
Yeah,
but that was all by design, though. The forest river level having no enemies, that was completely design oriented.
Yeah.
Edit this out.
That's cool. That you find that happens a lot in like game development. Like, you try something out, and like the only way to make it work is just sort of kludge it together, and like, because we only had like 4 flat levels, it wasn't a huge deal. So anyway, that's the one thing. Where was I going with this? So we talked about reusability, and so you mentioned functional programming, which is something that I wanted to like go into, and I want to try and sort of give a sort of example based overview of like Casey's compression oriented programming too. So the thing with, and I think we're going to actually get, when we start looking at the code for the Pong game, we're actually going to have an example of this too. And so the idea behind like functional programming, which sort of hopefully you've encountered before, is like, you might have a method, and hopefully it's like a static void. Well, it can return whatever No, yeah. So that's actually a terrible example for come to think of
without
it.
the data coming out the other end.
I was like, we actually need some return value here. So, um, yeah, so static foo, um, calculate thing, spelling, and then, it maybe takes a bar. And, it does some stuff. And sort of the thing that makes it functional, obviously, is the fact that it doesn't like go out, like it might say bar, like new foo in F equals. I'm just like coding on the fly. New foo, yeah. I'm just coding on the fly on a whiteboard. Yeah, it's great. Dot x equals bar dot y plus bar dot z. Just some nonsense. And return.
It's calling anything it's using is being used for what it was given, it's not calling out.
So it's not going off like global thing dot frob. Like it's not running off to other bits of the code and mutating state.
Right.
And it's like, because it doesn't do this, it becomes very powerful because for a number of reasons. One is you can really easily trace what it's doing. Like you can just treat this as just a single unit that doesn't do anything hairy.
Like, so there's your compressibility in the sense that this is a compressible item, or if your compressed objects or if all your code is made like this, so it's much more stackable, right? It's much more glomable.
Like, I mean, like the analogy isn't perfect, but if it's off calling this other thing, it's kind of like having a block that looks like this, and then it's like, it's got this like weird like puzzle piecey thing that like that has to,
like rather disgusting.
Yeah, that has to go and like plug in. That has to go and like plug into some other block. This is the global thing block with like a frob or whatever we called it. These two are now linked, and so you can't go and say, right, well, that thing, I actually want to move that block in my like little block tower somewhere else because it's like stuck on this. And so, and the thing is, like, you want to avoid this as much as possible. And, there's software out there that is like,
nothing but that.
It's pretty much nothing but this. Like, there's every single block. It's like, oh, it's grabbing in some global state. And, here's another block sort of just wedged on the side there. And then, we've got like another block, here, and, another one here. And then this one might have one like here. And so you've got this like wacky amalgamation of just stuff. And then, obviously to make it support this, you need to suddenly stick like weird like shims in between and stuff, and like like it just becomes an absolute nightmare to work with.
Yeah.
And so that's sort of like functional programming is a really useful tool to try and make sure that your blocks, sort of your just components of the program, are independent of other components in sort of an easily separable way. Like there's always going to be some, you're going to have to link these up somehow, but it's helpful if that linkage is really simple and obvious. Which sort of brings me to the other thing I wanted to talk about. So let's bring up a new layer. And that was, so I want to actually get into Casey's like compression oriented programming. So one of the things he does, because like one of the things that Casey's compression-oriented programming idea gets to is like getting away from object-oriented programming. And sort of the idea behind that is like there's nothing wrong with objects as such. You know, objects are fine, but objects I've ran out of space on my thing. Programming. You get the idea. Object-oriented programming, like the oriented bit is like the bad bit, is the bit you want to avoid. And there's lots of ways to avoid it. And one of the ways that Casey does it, particularly because he programs in just like straight C or pretty much straight C, you know, he has no classes. There's no such thing as a class method. He's working on just standalone methods, which, you know, are often functional. And the way that he builds these up is like, he might have a method like, let's say, and it doesn't have to be functional. I'm going to step away from functional for a bit, just to make things clearer. But like, let's say, I want to say, like, I'm trying to come up with like a concrete example. So let's say, and I'm going to switch to C# again, just to make it obvious for us. So we've got like a static method, and it's going to be void. So we're okay with touching some global state here. And, you know, he might have like frob allocate, and, you know, this might be like, you know, int number of foo, and then, you know, int number of bar, and then maybe these are arrays of like integers. Unfortunately, yeah, having a concrete example would be better, but this is, you know, like foo array int bar array, you know, and this is a method that maybe like goes and calls out, let's return a void pointer, and it calls out to
thought we were in C# again.
C# has pointers.
I guess. I guess so.
Safe.
There we go. Yeah.
And I'm trying to. It's been a long time since I've used this. Like maybe it goes like H. What is it? H global alloc. I'd have to search for it. There's like a win32 method that allocates like address space. And, you know, maybe it does a calculation, like we won't worry about what that is, and maybe it reads some of these things. And then, so maybe we have that method, and then like, let's get really fancy here. Let's be like, okay, so we've got that method, and then maybe we have another method that's like similar, and it might be, whoops, sorting out my paint program. So it might be like the same sort of method signature, and it might be like frob process, and it might like, I don't know, load this data into a thing, and, you know, blah 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 blah. We don't really care what it does at the moment. We're just looking at the method signature. So at this point, you know, and we might have another method that has like a similar method signature. And the point that sort of Casey makes with a compression-oriented program is like, you notice that, oh, look, I've got that there, and I've written another method that takes that there. Maybe, you know, and maybe I have like a bunch of other like maybe there's 2 or 3 other ones that are taking all the same data. So maybe I need to make like a class frob data that takes like int number of int, and then int array.
You're not designing this as a class?
So the whole point is rather than starting with this, you start with the static methods and the method signatures.
Right.
And you recognize that, oh, this data that I have here is all grouped together, and I'm constantly passing in the same, 1, 2, 3, 4 arguments. Let's now combine that into a class.
Okay. But isn't this more of a sort of a not, I don't want to say rudimentary, but like a perfunctory aspect of refactoring, where you want to reduce the number of parameters, but that's not just the main goal. The main goal is just to create this frob data to put it in there. I'm just curious. I guess, is it the point that you didn't start with frob data, the
Yes.
main goal, and that it's the act of moving backwards.
This is sort of the primary. I don't want to say canonical, but like sort of the introductory example of what you would do for compression-oriented programming is. So, and it is because it's as an alternative to object-oriented programming. And that is, you don't start with the object, you start with like a bunch of methods. The other way to think about it is particularly if this, rather than being a class, because we're in C#, this is sort of relevant, is if this was a struct. Because
in the back of my mind, I thought we would talk about allocations when we talked about functions versus stateful classes.
So, like the thing that's important to think about here is that now, more or less, these are equivalent. Like if you were to replace this with like this whole set of parameters with a struct, the thing that the CPU does is the same. Like it,
right?
And that's sort of another important point, is just recognizing what the CPU is doing. So like, you've got, hopefully this is all familiar, you've got like a stack, which I don't know if it grows down. I think it does. You've got basically a stack and it's growing downwards, and we're about to load. What do we have? We had like an int count, and then we had a int count, and then we had like an int array, which is actually going to be a pointer to where that data is in memory, and then an int array. If we're just combining all of that into a struct, then it's like, we got whatever was on the stack before, and then this is just our, frob data, and it's, element by element equivalent to what goes on the stack. Now,
if we had made it a class, it would be different, though, right?
Yes. I will actually say that this is not completely accurate, because this disclaimer, registers, these get passed in CPU registers depending on the calling convention, rather than on the stack. But sort of conceptually, it all gets passed on the stack. Whereas if we'd made frob data a class, and this is just like a C# thing, then this would be like effectively a pointer
Right.
to that data
Exactly.
sitting on the GC heap, which is fine. Like the way that Casey sort of would explain this, I guess, is like, what I'm saying is it's equivalent for C and C++ versus C#. If you think of this as, you're converting it to a pointer. Okay, so that's
that all makes sense to me. Other than I know that people make weird faces when you create mutable structs by way of having arrays within them.
Yeah. So that sort of way of programming, I'm not sure it makes that much sense. Like, it makes sense if you're thinking about programming as like you're programming C#. Whereas, and that's partly because C# is not like, struct in C# is like a kind of a kludge to get around the fact that this is going to end up on the GC heap and like cause garbage collection and all of these issues that you might want to avoid for like tiny data structures.
Right.
And then because basically when you have a method that takes a class like foo, bar, like depending on whether that is a class or a struct, if this method goes b equals b dot q equals 1, that method will behave differently because C#, depending on whether this is a class or a struct.
Right.
And whereas in like C or C++, like you would indicate that with a pointer, like to differentiate that situation. So that's why that convention exists in C#. And that's a perfectly fine convention if what you're doing is programming C#. Whereas if you are trying, and I mean, obviously C# gets in the way of it because it's garbage collected and jittered and all kinds of nonsense. But if you're programming like the CPU, or at least, a relatively close notion of what the machine is doing, that distinction there is more or less irrelevant. It's like, I would like, what you're thinking about, hopefully, is this situation here. Like, I am passing, 1, 2, 3, 4, 16 bytes of data into a method, or I am passing in a 32-bit system 4 bytes of data, and that's sort of the level where you'd want to make that decision if you're programming games, particularly if you're programming sort of. That's the way you want to think about it and conceptualize it for game development,
right?
Where you care about sort of the performance and where data's getting copied and how much load you're putting on the GC and all that.
Right,
stuff.
and to be clear, we almost always would prefer the center column to be more like passing data raw, as opposed to paying for the cost of the 4 bytes for the pointer when you have to go get that data from somewhere else anyway.
Well, yes and no. Like, there are situations where you want this one, and there are situations where you want this one, and the point is that you want to have an awareness of which one you are actually doing and where you want it to happen. So like if this was like a 500 bytes, like you wouldn't want to pass it on the stack. You'd want to pass it as a pointer, or there is in C#, there's like ref,
right,
to pass it that way, which collapses down to this as well. The way that
Yeah, I was thinking of it more in terms of like you want your functions to not have to, um, you know, there's no opacity problem if you're passing an object that's so large that you have no idea what's going to come out the other end, kind of thing, as opposed to if you have smaller methods to pass fewer bytes of data. But I guess that would end up just causing like a unnecessary method proliferation problem, more than if you're purposefully trying to create smaller packages of data in your arguments. But
maybe that kind of gets back to like this situation here, and it's like, well,
right.
You know, maybe I have a whole lot of small methods. Maybe it would be better if I just had one method that does everything. But
then why don't you just pass in a 3 gigabyte object that has the whole world in it?
Because that would take time. But that's exactly why you want to know. It's like, well, I know that this object is huge. I want to pass it as a pointer.
Of course, right. Okay, that makes sense to me. Yeah,
and
of course.
What I will say is one thing you can do in Visual Studio to make this process really easy is like the syntax highlighting is aware of whether this is a class or a struct, but you have to go and actually change that setting.
Yeah, I think I have on my theme. I have it set up that they're just like different hues of teal.
Yes, so I think. I think I've like pointed out that one to you in the past. I think is there. Yeah, so I have it really subtly, but like you can see that this vector2, which is a struct. If I mouse over it, struct vector2 is slightly darker than this one, which is like class sound effect.
Yeah. Mine isn't quite the same. I think I got like mine off Visual Studio themes, but same idea. Yeah. They're like the same color because you want to know that you've got an object of some kind. Where logically it's a thing of stuff.
Yeah.
And then there's the subtle change to whether or not it's going to turn into a pointer or if it's going to be in line.
Which is like and. Yeah, that's exactly like right with the C# thing there. Whether or not this is why they make them immutable in C#, but it's like, well, we're not really trying to program C# applications. It's games, so we want to know exactly what's going on, and we want mutable structs. Like that's an important thing that we might have. Because I mean, like we go into the code over here, and I mean, I'm not sure I'm going to find one necessarily, but hopefully I can in the update method, perhaps.
Hopefully you can't if you're looking for a class in there.
No. So ball velocity, which is a vector2, which we know is a struct. We're mutating that y element.
Right.
And so obviously that wouldn't be allowed if you're following the C# coding standards. The what is it, the style cop or whatever would be like no. But we actually we want to do that for like performance reasons because the thing is and this is a really obvious example. We might have a whole lot of methods like this that where's my that take x and a y, and we had another one down here that took an x and a y, and we've noticed that all over our program we're passing in x and y coordinates. Let's bundle those together into a struct. So that's sort of like a whole lot of philosophy stuff, and that covered a lot more ground than I was sort of planning to get to, but hopefully it's good, and hopefully that will sort of inform what we're going to talk about here. So first of all, what I wanted to do was just to demonstrate the problem with collision detection. So what I was going to do is I was going to say ball x equals mouse state ms equals mouse dot get state ball state ms.x and ball y equals ms.y. So hopefully that works, and I'm going to run it, and you'll notice that like I can move the ball around with the mouse.
Mm-hmm.
And this is sort of one of the reasons why it's helpful to separate out collision detection from collision response, because you can just sort of do this as like, oh, it collides, doesn't collide, collides, doesn't collide. You can tell where the collision is happening. And so what we can do is we can go down here and notice that like this lower section isn't colliding.
Yeah.
And if we go up here, this...
And that's why I tried to do some form of visualization on it to try to help in that regard, but
yeah,
obviously it's pretty...
But that's all right.
Yeah. Some math issues for sure.
So let's see. Yeah, so this is kind of my fault, because I wanted to give you the tool for the Minkowski thing to like make it easier to like make it possible to reduce the amount of code that was necessary. But I think like because I glossed over it so quickly, I didn't give like a full understanding of what was involved. So what I want to do is go back to the whiteboard and try and give that another shot, like try and explain the idea again, because I think I have a better way of explaining it too. So let's see, I'm just checking what I want to talk about. Okay, so what we did last time was like, we had, we have the paddle and we have the ball, and I was just basically saying, if you have, the ball size and the paddle size, if you add those two things together, you can like get a sort of large object which you can then like do collision detection from, a single bounding box, the big one that you added together, versus a point. Whereas if you don't do this, you've just got, an axis aligned bounding box versus another axis aligned bounding box.
Right. The rectangle solution.
Yep.
Or you're just checking the intersection. So
the way to simplify that is, let's not think about it in 2D. Let's think about it in 1D. So on this side, let's do this one first. On this side, we've basically got, we've got a range here, and we've got a range here, and we're trying to see if these two ranges overlap. And the way this works is it's like, let's say this is, how to label these? We'll just go A, B, C, D. And the way to check if these overlap is it's like, we want this space here. So it's like, is C greater than B? Or these two things could be flipped. So, it could be the case that like C and D is down here. So is that, or is D less than A? Which is
I don't understand.
Which is a confusing. So,
what do you mean by C is greater than B? C is over there.
So we're writing out the condition for if they don't collide. Mm-hmm. So if not that.
I get it now. Sorry,
That's all right.
Yeah.
So do the collision. So that's how you do in one dimension this segment versus segment collision. And this does assume that like this is like a positive thing, and like D is greater than C. And obviously what you'd actually want to do is you want to flip this condition around so it made a bit more sense. So usually it's be like just to make things like clearer, you'd say if C is greater than B, or is A greater than D, just to make sure these signs are the same. So that's that method. Let's do the same thing over here. So what we've done is, take this vector.
I think isn't it? I think the first part is C's shouldn't be greater than B in the red line, right? Because it's already greater than B in the other, isn't it?
C greater than B is if C is greater than B, or if A is greater than D. Yeah, no, this is correct, because this is like the same. I've just taken this whole component and shoved it out just to make it less.
Oh, okay, sorry.
I should have just done this.
I thought you were inverting it for some reason, but you're not.
No, I just wrote it unclearly. So is A greater?
Yeah, we're good.
Yep, cool. So the way to think about this one is, we've got our A and B, and then we add on CD in sort of like we take this vector here and we're adding it on to this vector here. So we go there, and we're using C and A as like our origins for these sort of quote unquote objects, these segments. So
right.
So what we have now is we've actually got a line segment here and just a point here. So this was C. So I'm going to relabel these. I'm going to use capital letters just to make it clearer. So this is going to be A, this is going to be B, and this is going to be C. Actually, no, that's not very clear at all. Let's call this Q and R and S. And so the way this looks sort of mathematically is if C, yeah, not that. R can be down here. If S is greater than R, or if S is less than Q. So this inner segment represents the case where this point is outside. So does that make sense?
Yeah.
Cool. So the thing is, the way you derive this is...
I mean, it makes sense if you give S and R, I'm sorry, if Q, R, and S are actually being treated like points. Like, I know C was a point. Q and R are now like the extents of the vector?
Yes.
Like
so
what are...
So
yeah, sorry.
That's all right. So what we've basically done is we've basically said that... I'll color code this too for great production value. So we're basically saying Q, R, and S is equal to Q is equal to A, R is equal to now this is where it gets a bit confusing, but like let's just say B for now,
I'm having a hard time. Like I know they're not scaling anything, so they're not being treated like scalars, but they're not positions either. They're just components on this vector. But whatever. I mean, I get it. I just tried hard to use the right labels for what these are.
S equals C. So does those three equations that I just wrote down make sense?
D minus C. Yes. Q is A is easy. S is C. Sure, you're just calling it C or S this time. The R bit is where you take B and you add D minus C. I mean, I guess the line isn't the right size, but yeah, I get it. Yeah.
Okay, so what I'm going to do is I'm going to modify this slightly, and I'm going to make this vector explicit and this vector explicit. So this is going to be U and V. Okay, and so this becomes A plus U plus V. Does that make sense?
No. Hold on. I'm just trying to. So I mean, if I'm at A is you said was the origin for this purpose. Right. So
Yeah.
So you're just adding the two vectors together. That's how you get R. Yeah. Okay. Sure. Yeah. That's the simple thing. That's just like you took on the left side where you have Q and R. You've just taken the vector U, and then you've added the vector V. The origin doesn't matter in this case. So yeah. Sure. That's how you get R. That makes more sense than the previous thing to me. But
so this step here where we've said, well, we have an object, we have a quote unquote object, like we have a not an object in like a programming sense, but just a thing. We have a thing at A, and it's physically is that big, and we want to do collision detection versus an object at C. So this is the Minkowski step, and that is that we've taken,
you've added the vector.
The size of
it's the same.
The first one and the size of this one, and we've ended up with this is the extents that we can then do comparisons with. Okay. So we're taking one size and adding another size to get a new set of extents there, which is really, when we get down to it, this is the red ones here. And then what we can do is, that all ends up in this one. So, and that is how these two are equivalent. So does that whole process make sense?
Yeah, I think it does. I mean, if you just visually see, yeah, okay, I get that.
Yep. Okay.
So far, so good.
Okay, so basically, we then, like, if we wanted to extend that out into 2 dimensions, say we have, this is our paddle, which we're going to call like object A, and this is our box we're going to call object B. Rather than taking like the top corner, we could take the top corner. In fact, let's take the top corner just for simplicity, just to keep it the same. We have here's the size of this object. Here's the size of this object. Okay. What we're going to do is we're going to add on this. I'm really complicating things by changing my labels around. But we add that on, and then we get this object here in 2 dimensions.
Right.
At which point we want to compare it against this point here. So it ends up being the same as this, except we've got like we check on this axis, like, you know, AX, BX. Let's change the name of this because that's silly. No, wait, sorry, my bad. That actually should be B now. Yeah, I've confused the labels here a bit because this is also BX. We've added AX and BX, and we say this is going to be object N and P. So what we would say is, yeah. So I've gone to confuse myself by trying to launch this into 2 dimensions with weirdo labels. If, and we want to get if they're colliding, so we add the not in there. If N, which is going to be this point here, if and P is going to be this point here. So if P is less than N, or P is greater than, we're going to do x-axis, nx plus ax plus bx, and that's the first axis. And exactly the same thing if py is less than ny, or py is greater than ny plus ay plus by, then we have a collision. Now, does that make sense?
Sort of. I mean, where are you getting B? Where are you getting the Y components from? Because I know we're using the top left. So PX is just what? These are positions now.
So these are all vectors. So we have in this equation we have 4 vectors. We have P, we have N, we have A, and we have B.
Okay, just hold on. I'm going to trace them all. I know where I see P, I see N.
So these 2 represent positions, which I've labeled. So now I'm going to fix up my labeling because I've done a poor job labeling these. So this one is B. This one is also B. These are the same vector.
Right. Okay. Yeah. That makes right. A. That's how you produce the.
Yeah.
What is it? Sorry. What is AX?
AX is the x component of this vector. So AX is that distance there.
Plus BX.
So
yeah,
B,
I guess. I mean, it made more sense in 2D it made more sense when it was a number line. But I mean, I know where you're trying to get, but my brain's just scrambling up all the numbers.
That's okay.
But so PX. I mean, I wish I could draw on the same board as you, so I could say, is this PX?
So PX is arbitrary. So basically, we might have origin 0, and so this is like the vector that places N and P somewhere in the space. So these are the ones that are like completely arbitrary and move around as like our paddle and our ball move around the screen.
Mm-hmm.
Whereas the sizes, obviously, in like a Pong game, they don't change.
Right, they're fixed. Right. Okay. So if I just look at it in terms of, right, if the position in space of P is less than the position in space of N, in other words, it's behind it. If it's not true that it's behind it, and it's not true that it is in front of it, but not just in front of it, but in front of the entire derived volume of adding the 2 vectors together, then you're actually inside it, and then you do the same for the y-axis. Yeah. Mm-hmm. Okay. Yeah. Yeah. It makes more intuitive sense than it does when we look at the numbers. But yeah, I understand what I get it now.
Okay. So
you're just sliding these boxes around and saying, if you're all the way to the left here, all the way to the right, you're past, like, you're not overlapping it visually, then Like if you're not past it to the left, you're not past. If P isn't slid past N box, and P hasn't slid in front of N box, then it's inside it. Yeah,
And
I
I'm
get
just
it.
trying. Now I'm looking at this, and I'm just wondering whether I've botched the maths.
Yeah, I mean, I'm not really looking at the math 100%, but I am seeing. I mean, I can see the AX plus BX. I can see you doing the creating the volume that includes includes the size of whatever you want to call this CBBB thing, the ball in the game.
Hmm.
Um, and you're doing the same for the y-axis here.
So the thing that's got me confused, because okay, so we've reached a point where I may have confused myself. So now if we draw this out, because this is why I was going for like center positions. If we draw this out, like what happens if that's N, and like that is P here?
Isn't that the problem my game has already? Like that,
Quite possibly.
it doesn't like because you get penetration in some cases, and you also get like hitting nothing, hitting air, and I think that might have to do with whether I'm considering the origin properly or whatever.
See, this is why I wanted to use the center, because
Yeah,
this situation ends up with like a box around there, and so if our n is inside this outer box, you get this situation there, and you're actually colliding.
hmm
Um, so I'm now thinking, how have I messed this maths up? Because it's obviously I've made a mistake here. Hopefully the explanation worked.
yeah. I mean, I understand what you're trying to do. I don't think it's going to be useful to correct the math because my grasp is tenuous anyway. So, I mean, I can read it out read out what you're trying to do, um, and visualize it sliding around in space. But
Oh man, I'm not feeling good about this actually, because I've made a maths error, and it's something that I have to sit down and actually now work through, which I'm not so thrilled about doing just like on the fly. Um,
well, that's okay. We don't have to. We don't necessarily have to even post this one or
that's all right. That's okay. No, we like this is the thing about doing these things live, is that there may be mistakes. So
Yeah.
okay, let's go back to the code now, because I think you at least understand the concept, and that is you can convert these two lengths into that length and
And then check a position to be outside or
shift it around.
shift it around. Yep. And I thought I was doing that, but then I got all messed up about the origin thing, and
I think
I think I
what
probably Googled something about if the resulting calculation is in the origin, then it's a collision. But I think I could have just
okay. So
continued with that.
I think you can see the mistake that I've made, and I've completely fucked up the maths, because what actually needs to happen is you actually need to be calculating P needs to be down here now. And that would mean that, if P is down here and it's outside this orange box, you've got no collision. Whereas if it moves like down inside the orange box, you get a collision. So it needs to be the bottom right corner.
Right.
And the same thing here, like you actually need
Right. Otherwise, you have to
P.
be fully penetrated inside of it in order to count it as a collision. But it's obviously
Yeah.
hit you a little before that.
And I've actually made exactly the same mistake here, because this actually should be D. And so, you've actually got this situation here, like the segment is that segment there. And so if you've got the D point, if it's there, it's outside, and if it's there, it's inside. So this S should be D.
I don't know how that changed anything for me, but that's okay.
It's because we're colliding these line segments. So these line segments are equivalent to these boxes.
Right.
And because, yeah.
Oh, I see. Yeah. The C is the top left. There's no top, but it's the left, and D is the right.
Yeah, I think I've made a simple maths error somewhere here. And because that I usually do it like this, where the direction literally doesn't matter because I'm smack in the center, I've stuffed it up.
Mm-hmm.
So anyway, the whole point of that was just to try. I think I may have made it worse. The whole point of that was that we could go over here to look at the code for. Is this still running? Yeah, it's still running. To look at the code for this collision detection and talk about like where it's kind of going wrong. So we have this method collision detection trick. And so what's happening here is we're getting the ball center and ball extents. So already we're doing like the half size thing.
Mm-hmm.
And that's all fine. We've ball center is X and Y. Yeah, and then we're creating an AABB. So we've actually gone sort of you've created where is the GIMP? There it is. So we've already got the ball center,
Mm-hmm.
and we have the half size, and then you've gone and created that, and you've doubled the half size, which gives us the equivalent of that corner to that corner. So that's so far that's fine. That's like that's what you would expect. So then we get down here to the Minkowski distance, and I think this is where it kind of goes off the rails, because we're taking ball extents left. Okay, so this is all the same. This is the same thing as this, so that's fine.
Yeah, I just have a class to shove it in, so I gotta do it for each thing.
Which is fine. And then it kind of goes a bit crazy here.
Sure. Okay.
So part of the reason it's a bit weird is because you're doing a bounding box versus origin. So you'll notice there's all these zeros in this column here, whereas over where we're sort of doing the maths.
Yeah, we were actually talking about it in terms of the other like the other thing we're checking against, not against some zero point.
And
I think I googled that center origin thing because I don't think we had like a other than like Wikipedia, like a blessed resource for that. So I read a thing and somebody said, oh well, you have to check it against the origin. So I did that. But now that we've described it here, I wouldn't be checking against the origin. I'd be checking against, if the ball is P, I'd be checking it against N or whatever.
So I think you may actually be onto something. This may actually be the root of the problem between like, is P here or is P here? I think possibly if you do if you're working everything against the world space origin over here, this may actually make this bit of maths work out nicely.
So basically I've taken the strategy of a top left and tried to apply it to a strategy that uses the center. And that's why I'm like in the ballpark, but not.
Yeah. So,
not working out.
And I think, yeah. So what I'm going to do, because basically, like this is, I think this is my fault. Like I've overcomplicated this. When maybe it didn't need to be overcomplicated. So what I will do in a second is I'll show you what I did to solve this. What did I want to go over? There was something I wanted to say. All right, don't worry about that. Okay. So where is it? Let's stop this one for a moment. I'm just going to bring out this one over here. So this is my test that I did before. Oh God, it's going to make noises.
No, I can't hear them.
Okay,
I guess
cool.
it's only you.
It's really quite shrill in these headphones. So this is it. It's basically the same thing. But the way that I handled this was I have this method here that should probably be static, come to think of it. And this method you'll notice is very similar to what we had on the whiteboard before. So it's structured like this. It's like, does an axis aligned bounding box contain a point? And
Right.
The only thing is, like, I've just gone and combined that term, that term, that term, and that term into just like a single thing that I pass in. So where's it going?
You're using min and max in yours, isn't that top left and
Yes. So
bottom?
basically, and so if I go find all references and I find the two places that I use this,
That's the X and the Y.
I've got the I'm passing in, the ball position is the point that I'm testing against. Then I've got the paddle position minus the half size, the paddle position plus the half size.
Oh, so you're sliding it around.
Yeah. So if I visualize this, okay, so I have what's happened here? Here we go. Okay, so I have a paddle sitting in world space. It's at some position here. So what I'm doing is I have the half size, so I'm adding it and subtracting it. So to get the 2 points, min and max. So then I just have 1 point, 2 points, and I'm passing that into a method that compares it to like some other point P. And then this is the same thing we did before. Is P greater than max?
Yeah.
That way, or that way. If it's outside, it's outside. If it's inside, it's inside.
Yeah. And this function you've written doesn't care about Minkowski or anything. It's already been derived what the min and max are, so it's generic to whatever.
Yeah. So
it's a very basic test.
So and then what this is in actual fact, our ball would be here, and our paddle would be here, and then we've done this. Should hopefully look very familiar. This like Minkowski thing was like out and add. Okay. So if I look up the paddle Minkowski half size, paddle size plus ball size divided by 2. So does that make sense?
Yes. Yeah. Yeah, of course it is. Yeah.
So like that, because this is like, see, this is the thing that I wanted to, like, this is the reason that I was like, oh, you should probably use this because it makes the code a lot simpler, is because it's literally that line of code, and then this one function that
you subtract it to make them in, you add to it to make them the max, and that takes care of the penetration of the ball inside because both things are centered. So yeah, right.
Yeah. So that's why I was like, yeah, use that because it makes it simpler. But obviously that was my mistake because it actually ended up making it a whole lot harder. So you see, you've got like all of this stuff here, and then all of this stuff here.
Well, sure. I'd never done it before, so I was looking at it like a math problem, and not like an intuitive moving shapes around problem.
Which is fine.
Which is actually leads into your, when you told me I need to start looking at like this video series on linear geometry, because if I can think like that, then it wouldn't occur to me to write out all of these calculations to do.
Yes.
To just get my things in line and then make some funky, like looking at it like the mathematician and not visually.
Yeah.
Just moving the stuff around, which makes sense.
Yeah. So that's like it's not like a problem, I guess. I
mean, I don't feel like a bad programmer because I didn't get it done in 2 hours. But and like we said before, like if I was going to do Pong, I would have done the extra computation of 2 axis aligned bounding boxes as opposed to trying to get away without doing that.
Which is actually like, it's not actually that much difference because I mean, it is axis per axis. It is, it's 2 comparisons here. It's 2 comparisons here.
Mm-hmm.
And you just like, do you add, do you add stuff and shuffle it around or not? Okay.
Well, I mean, I could always I think if I started my clock and redid it, I could probably get it done.
Yeah.
Not 100%, but
that's okay. So that was only like part of the exercise. And the thing is, like, the main point of that exercise was just doing vectory stuff. So that was the other thing that I wanted to like. So now let's have a quick scan through like this code and talk about just some of the other code stuff in here. One of the things that I would say is, because up here, we've got all of these integers, left paddle, right paddle, X, Y, all X.
These are vectors. Yeah, they should be. Well, that's the thing. Like when I think about it, like if I was going to, you probably maybe weren't even thinking of this, but if I was going to take the left paddle and make it a vector, the whole way we've been describing vectors is it's not the numeric representation of 2 things that I can, store. I'm not trying to store it. Like a vector to me, when we've been talking about it, is like a distance and a direction. Yeah. The left paddle isn't a distance and a direction. This is where it is in space. It's a position.
Yes.
It's a coordinate. So, sorry, maybe this doesn't mean anything at all, but if you're going to tell me to make that a vector or use floats or something, I'm not sure.
Okay, so...
But go ahead, sorry. Tangent over, probably.
No, well, so you recall what we were saying, like, in the first sort of session was basically that, a vector could be like, here's the origin here, and, we have a paddle out in space, and, that is the vector there that represents where in space the paddle is. And so if we had another vector like there, maybe our paddle would move over to here in space.
So it's hard for my brain to see positions as vectors just because there's like an implied sense of motion in my brain. And we're talking about motion that's already occurred, not motion that's occurring. So it's like a little weird for me.
What maybe you can do is like, well, the thing is like everything is vectors basically, because this, like if it's moved, that is the vector of motion. So if this is position A and this is position B and this is like velocity, we've gone A plus velocity equals B.
No, no, I
Yep.
I understand that. I was just trying to break my
Hmm.
programmery notion of, well, I'll just store something here because it's two things. I know, but I get what you're saying, and I'll probably get there eventually once I watch enough of those linear geometry videos. But
Yeah.
um,
So the reason I want to suggest that you do store these as vectors is
mhm.
precisely because you can do this calculation like this. Like if these are all vectors, you can make like this calculation is like one line of code. I mean, it's the other way. It's like b equals a plus b.
Right.
Whereas in the other case, it's like new b equals new vector blah 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 blah. You got
Right. Yeah.
x
It's
plus
definitely more terms.
yeah. So
Okay.
that's worth doing. But like I mean, the way you're thinking. Sorry.
Sorry, am I casting it there too? Is that another reason to use floats? I don't remember what I wrote. I did it on a train, I think, but I think it was whether I was doing like too much like casting from float to int.
Yeah. Well, that's implicit.
I guess
Like,
well, this implicit, yeah, it would have been
so
in
like that's not a huge deal. But what I wanted to say about that specifically is whether you're in int or float. Like this is why I don't like X and A's point class, because it doesn't have operator plus and minus and so on. And you recall in River City Ransom we had position, which was X, Y, Z.
yeah.
Which is
They're
equivalent
all
to
integers, obviously, for our purposes, but
which is equivalent to the vector 3, and it had like all of the operators, and it is exactly the same basically, but it was integer and it was float. So whether you're an integer or a float doesn't matter. Like the important point is this, that you can add and subtract them together. So I definitely yeah.
Sorry, from the compiler or from the CPU, maybe, or even possibly the GPU point of view, is it faster to do that than to ham-fistedly type out, this plus X plus Y or whatever? Is it
Okay.
faster to add, or not? It's just going to be running the same kind of operator code in the background.
Almost every circumstance, and pretty much any circumstance you care about, unless you're micro optimizing, it's exactly the same. Like basically the same thing as we were saying before back. Which slide was it on? Here. Yep.
Mm-hmm.
This frob data, this could be a vector. You've got an X and a Y. If you're passing those as integers, if you merge those into a single struct, they still get sent as if they're individual integers when they get passed around. Mm-hmm. And there's some sort of weird things like, and a lot of this got fixed in like C#. For C# specifically, got fixed in I think C# 3 or 4 or something. Sorry, .NET 3 or 4. And that it wouldn't because this thing I was saying before about passing them on registers, like this would get passed in a CPU register and this would get passed in a CPU register. Whereas if you combine them into a struct, back in the day, they'd actually get copied out onto the stack, which is a bit slower than just leaving them in a register.
Mm.
But I believe that is fixed, and that's just some like quirk of using C#.
Okay, something in the IL was
and I think they fixed that. And so the only circumstance where you'd worry about that is if you're micro optimizing. Like I remember that this was a thing that you had to do back in like XNA 1 on the Xbox 360.
I remember that generally being slower than like most of the things.
Yeah,
there's a lot of stuff you couldn't do
because it was not running on the .NET framework anyway. It was on the like
right
micro framework.
And it had had no GC, or it had its own brutal GC. Like
the GC was nonsense. It was terrible. So yeah, that's basically, yeah. You don't need to worry about combining data types into structs.
Okay. This is simply just for the code is more clear because
exactly.
less,
That's the important point. Like, you can always go and micro optimize things if it's necessary, but like reading it takes up so much more programming time, and like understanding it, and like having other people read it, and like, you know, you come back to it a year later, and you know you need to be able to read it. So you need to make the most sort of readable thing possible way before you ever consider like how fast is this going to be.
Yeah, that's true. I mean, even if it's like, I mean, we worked on River City for like, 3 or 4 years, so there's lots of code you wrote, and you didn't go back until like a year later to see what was happening. Yeah, you better remember how it works.
Yes,
for sure.
Okay, so what else? I think we've pretty much covered everything. So there's two things left I want to cover. One of them, real quick, is in your code. It's detecting a collision, and it's only by a fluke of just the way the numerics work out that it doesn't end up doing. And let me get my drawing in place. So we've got a paddle, we've got a ball coming along, and it collides like this. And when it collides, it runs. Okay, so it runs collision detection tick, and it sets a flag, and it does.
Right. Although I'm already feeling gross about that. I should have had a bool there. We were just talking about not using state, and here I am shoving all this state into the program file. But
yes,
I think I was just trying to get it done in a hurry. But,
that's right.
But absolutely, it's stupid. Yeah, I understand why it's bad.
I've just realized that I also there's a third. So that is actually the second thing I want to mention. There's a third thing I want to mention, and that is that this is just wrong. That should be that. Does that make sense? And I'll show you in fact how this works. So I'll turn.
Yeah, because I think if I hadn't done that, my brain is telling me that it would always just go back and forth along the x-axis.
This is actually really,
because the vector is actually already.
This is actually really handy for testing, because I can just leave it like this, and it will just keep bouncing up and down like that. But I'm going to go.
Is that how Pong works? I'm not sure if that's actually how Pong works.
So this is a problem with physics. So if I get rid of this line here, then it actually, notice what it does now. It actually goes like that.
I have no idea why.
Yeah, so
I guess because the vector has changed, the vector of direction has changed, but.
So let me show you, like, so there's two things that have happened. First of all, in this case, the ball hits, and what you've got happening is the ball hits this surface here, and it comes in, and it comes straight back out that way, because you've inverted both the x.
I've inverted it.
Yeah. Whereas what you want to do is obviously.
Oh, I get it. Yeah, I get it now. Because it makes sense now. But it doesn't when you're sitting in front of the computer going, well, you have to do something with the y-axis. But yeah, of course.
Yeah.
This is embarrassing, but
that's fine. Like, I thought I'd point that out because I do actually want to get into this later on. Like, I want to make a thing where we have a collision detection that is basically exactly the same, but a collision response that is the same sort of thing, but is not axis aligned. So we will have to do something with both the x and the y axis to make it bounce off that surface sensibly.
And visually it makes sense that would involve changing both axes, because you have to correct it. You have to correct where it is in space first before.
Mm-hmm.
Right.
So the other thing I wanted to say is if you were to get into the situation, and you may get into this situation if you use floats, just numerically, is if you detect a collision here, you're coming in this way, and then, you do this inversion here, and you go out that way. On the next frame, you might be, let's use pink for this. On the next frame, you might have it such that the box is like just like that, and it's still colliding. So on like the third frame, it registers a collision again, it plays the sound effect, and it starts going this way. And so on the next frame,
it's stuck forever.
That, and then, it does that, and it gets stuck forever. So that's something worth thinking about. Like that's an important thing to think about with collision response. So as I was saying, you have the two phases. You have
I did, to my poor credit, I did separate detection from response.
Yeah, no, that's exactly what you want to do. But you do need to think about that linkage there. About yeah.
I was going to say, in our CRU, the collision detection protects against this interpenetration thing. But I mean, we didn't have the float problem because we were in integers.
So on RCRU, we had a few things that saved us. One is that we were very careful to make sure that you couldn't get inside something, and if you did get inside something, it would separate out at the right point in the collision processing to make sure that this never happened. I'm trying to think. It's been a while, so I can't remember exactly how that code handled this situation. But the other thing is we're integer based, which you are integer based as well. So this saves you from this situation. Like this is what has saved your code from this situation, is the fact that you're integer based, and you're always moving at a constant speed. So you're never actually going to get stuck because you're going to be inside for one frame, and then you're going to move out the exact right amount to get outside.
Right.
But the only thing saving you is it's exactly numerically correct.
Right. Well, I won't be saved from that the moment I switch to use the more terse vector based.
So, the simple way to do this, and the way that I did it in my little test game, was just detect the direction. Like if you're going in, you can collide with the right paddle. And then on the left paddle, if you're coming in that direction, you can collide with the left paddle. Then the collision response does its thing, and you're suddenly going, on the right paddle. I know I've got right on the left and left on the right, but whatever. You're going this way, and you just detect that, which direction the velocity is going, and it's like, well, I'm moving away from this left paddle anyway. So there's no way I can collide. There's no reason that I would want to do a collision response with it. So that's the simplest way. And I think we did something like this on River City Ransom as well for handling the bouncing objects and stuff. It's if you're moving away from a surface, don't bother trying to do collision on it. Because
that's already happened.
Yes.
We've already done that.
In fact, come back. Now that I think about it, I'm not sure we do it moving left to right, but floors and ceilings are handled exactly like this in River City. It's if you've got a ceiling and an object that's moving downwards, we just skip over all of the ceiling collision detection, and we do the floor collision detection. And then by the same token, if you've got an object that's down here and moving upwards, there's no point in colliding with the floor. The separation step will actually separate it out, but it still won't collide.
Right. We don't need separation for Pong. We can just ignore.
Yeah. So
based on the direction.
Exactly. So that's the other thing that I wanted to mention. And then finally, I'm going to give you a link for this as well. So
that
The 70th thing wrong is
there's not that, like, it's actually pretty good. Like, it's pretty, like, it works. There's a couple of bugs, but it works. But the idea here is to, like, sort of polish it, I guess.
okay.
And so the one thing that I wanted to go over is this collision detection tick and this input tick here, and to a lesser extent, like, the fact that this, like, what you could have done is you could have made
that
this
needs to return. Yeah, 100%. Like, I wouldn't write this code in real life.
Static, and you could have made this like ref left colliding and ref.
I was gonna make. Oh, right. I'm not allowed to use objects, so I couldn't make a struct or whatever to give.
Yeah.
Or I would. Why not just return true or return a bool? In this
So
case?
okay, so what I'm going to say, like, I'm working through this in steps. So the first step you could do is you could have multiple return values to be like, right, we want to get data on this,
yes.
and that lets you make.
This is the organic thing. Yeah.
That lets you make this static, this method here, which, you know, and then you'll notice that because this is static, all of these have become errors because it's going and grabbing all of this data as well, and it's saving these. And I know you've saved these out because you want to visualize them, so that's not too bad. But this one here and this one here could have been a return value. Like, and then what you could have done is like collision detection tick left, and then make that a bool, and then you could have done, you know, left colliding equals collision detection tick left, just to, like, rather than having the multiple return values, you could have done just a single return value, and that would have made make a bit more sense too.
Well, I was thinking we don't need a left and a right because we could just detect that there's a collision with the ball and a paddle at all. Oh, but we will need that if we're going to be doing cancellation based on direction. Also.
Yes, and then that exact thing is where we get into this sort of final thing I want to talk about, and that is this method and this method as well probably shouldn't exist at all. And the reason for that is if I right-click this and I go find all references, you know, we find that it only gets called once. So that is not really adding anything. So what I could do is I could just grab this whole method, cut.
Well, yeah, of course.
And then, like, if I, you know, give it some space, I could just dump it straight in there. And at that point, you know, if I'm like, right, I need to come and I need to read this method, which I did have to do. Like, I had to do this to figure out what the code's doing. I want to know, right, where is the ball? Where is the collision detection happening? Let's go through this method. And it's like, well, it's not there. That's moving it. All right, we're moving it. Right. And then, you know, we get to here. It's like, okay, we're working out some extents, and now we're doing some collision stuff. So, and then I can keep reading, like, I'm just scrolling through the code, scrolling. Whereas if I'm like, right, well, where does the input happen? I'm scrolling through the code, I'm like tracking everything as it's happening. And then I get to this input tick and I'm like, right, well, now I have to jump over here and then figure out what the input's doing. And it's setting some global stuff. And then, I have to jump back and then do it again. And so, like, this is a really simple example because there was only two methods. There was input tick and collision detection tick. And they're in the same file, in the same class. And it's sort of like, this is really super small scale. But once you start getting to larger scale things, you almost, like, this should be the default, is having the code inline, because it just lets you say, right, I'm going to read this method. I need to know what it does. I can scroll through it in one sort of linear step and understand, like, all of what that method does. So sort of getting back to the stacking blocks thing, like, it's like taking a thing that's made up of three little blocks there and just turning it into one big block.
I mean, in this case, it's encompassing the entire game, right? I mean,
exactly.
I think the extraction of methods occurs almost pathologically when you're like organizing code. And I thought, well, I should gotta separate detection from response. Well, I'll put that out in a method. Now it's obvious that there's a separation that occurs, but this compressing thing is to move everything back into the method.
Yes.
But I feel, and it's funny though, because I feel like I don't do this as much as I used to. But then when you look at Pong, and I just wrote it quickly, well, automatically was going back to. I mean, I didn't create a million classes, but it's probably because he told me I couldn't. So I mean, I think, you know, if I didn't have that rule, you probably would have saw like AABB struct, right? And then it would have been, you know, and then I would have had methods on that.
Yeah. So and that's sort of the thing you get. Like if you start making an AABB struct, then you're like, well, what does an AABB struct have? It has like a collision detection method here, and it's got like, you know, maybe I want to add a vector to it to move it around, and like it's got all of these operations on it that you maybe don't necessarily need for like making what you're making. So I'm going to go back to.
But I mean, what you're basically just saying is like, you know, hire when it hurt, only when it hurts, kind of thing. Like you only have as many blocks as you actually need. In this case, Pong doesn't need more than a laundry list of code. Yeah. Whereas River City Ransom, eventually you do need an AABB because it's too complex to try otherwise.
Exactly.
I mean, I don't think there'd be a useful exercise to make the entire update loop in River City like one, like you couldn't do it.
Yeah. So what I wanted to like point out is like, so say we fixed up all this code, and what we end up finding is that, you know, this section here, this is the left paddle, and this section here, this is the right paddle. It's like, well, some of those have some common elements. Let's
just
identify those common elements that we're going to, you know, have multiple times. Let's copy those out into its individual methods. So it's very similar, and it is another aspect of what I would say is like the this business, the compression-oriented programming. So we've got, you know, we're passing in the same parameters here. We're passing in the same parameters here. Let's think about turning them into a structure. By the same token, we have, you know, the same set of code here and the same set of code here. Maybe let's think about turning that into a method.
Yeah.
And so I just want to bring up like this one here. Like this is mine. And so I've got start round here because this gets called like 4 times.
Right. And I think I have a similar one. Like
you do.
Because you need that little bit. Yeah.
And then I've got the update method, and I've got this AABB contains, and that gets called twice.
Right.
And that like the way that I programmed that was literally I was writing this line in my update method, and then I found, I'm writing that line again in my update method. So let's split that out into a method. So that's the point where you create a method, because like a method has some overhead, particularly when you're reading the code and trying to understand it and trying to like build more things based on it.
Plus the runtime has to like virtually find it and call it.
There are performance implications as well.
Anyway. I feel like I have a different way. Like I understand extraction type exercises. You know, I've been doing it for a long time, but I'm confused why I didn't just do that for this exercise. Is it a speed element? Does your thinking about things change when you have, you know, you feel like there's a clock ticking, or, you know, because this is like the bread and butter. What I do every day is write code in one spot and only break it out when it needs to be broken out, when I'm repeating myself. You know, like that's the don't repeat yourself, dry, right? It's one of those buzzwords. And you know, but when I think about dry, I think about how it gets taken too far to the point where you're abstracting just because
you're copying code, and not because like. So I mean, Pong doesn't let us get to a point where it's actually a bad thing to be arbitrarily extracting methods out, right?
Well,
So
okay. So let me give you an example, and I'm going to switch to this one here, and that is like this AABB contains thing. I would have like because it's sort of a sort of common mathematical operation. I was like, this is just the way that I do it, and that's sort of because I know that like not only is this code that has occurred twice here, but this is code that has occurred like twice there and like 30 times in like every single other project I've done that has like 2D stuff. So it's like my trigger for separating that out is actually quite sort of sensitive. I'm like, right, let's snap that one out right away because I know that I'm going to need that. But I would have, aside from that, I would have no qualms whatsoever with having that line of code repeated twice here and here.
right. I mean, it's not even almost saving you any keystrokes because of the fact that the line is long, full of data points anyway. So, like, yeah, I get it. And so what we're trying to talk about, copy and paste is not always bad, basically.
Exactly. So dry is like a really good thing to sort of have available in your set of tools, but it probably shouldn't be like the first thing that you reach for.
Right. It's not actually the problem, it's the hammer. And the problem is compression, and you should be using a hammer as part of your,
yes.
Whereas like a lot of people, when they hear the solid principles or whatever, they think the problem is your code doesn't conform to this ideal. And then suddenly you've got, oh God, Liskov's substitution principle, and then you're like all over the board with it. And then your code is completely unreadable by anybody, but it's solid. But there's a lot of unpleasant things that are solid too.
Exactly.
But yeah, that's what I knew. Yeah, but I don't know why. I don't know how I managed to just pull out that one method and then have a bunch of global state. I was thinking, it's Pong. Just do the thing. And also, you said simple, which to me probably meant copy, like don't extract any methods. But in my case, because my approach was so, I guess, verbose, then that actually does become a situation where you really don't want to be tapping that out so much, like extract that out. Although the better solutions would lead me to be able to throw that code away. But
yeah,
I get it.
And well, see, this is another thing that like it is going to be something that you will have to sort of think about yourself, and that is that like when you're writing the code, it may be the case that the thing like you're here and you're writing out like, right, well I need the balls to move, so I need move ball there, and then I need and that does all that stuff, and then I need to run collision detection there, and then I need like run response, and you figure out like bam 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 bam, those are the four things that this method needs to do. And then maybe it's just a case that your process is to write these things out as separate methods. And the thing that I would like, if that's your process,
I mean, use scope lines like.
Well, that like I find that works. Like I would never do that. But it may be the case that helps you like figure out what you need to type.
Well, I've never the thing, like I've never used scope lines in a method. Like I think I do somewhere. I picked it up completely from your coding style from the game.
Yeah.
Where it's like that must be like, to me I'd be like, well, I'm looking at it. It's a method. Sometimes it's a good trick when you want to use the same variable name and the same block of code, but you don't want to deal with it. But that concept that I'd never had before, whereas like sometimes I can scratch the itch by just using the scope line.
Yes.
But I don't think it's very common. A lot of people will look at my code funny when I use scope line. But I picked it up just from
Yeah.
the game itself because I'm looking at the way that you do it.
Yeah, so that and that's all part of this process of like inlining these methods. So basically, what I was going to say is like if
I
you
don't usually do that. That's the thing that like now the old me did, but post game me doesn't usually break a method out, and I don't know why I did it. It's baffling.
that's fine. So what I was going to say is like if you end up in this situation, either because like that's just your style, or because it's just ended up that way for some reason, or like you've maybe two things were calling this, and now you can be like, well, no, actually, only one thing needs to call it.
Right. You just want to remember to go back and
Go back through, and like if this class, like if I go to this drop down here, it's like, you know, all of this stuff. If I can reduce the number of things in this scrolly thing, the code just becomes that much more easy to understand and like think through what it's doing, which is really the like just in simple sort of time spent terms. It's like any time you spend reading code is very sort of it is relatively expensive, I guess. So
right. I mean, in terms of time and life, and you're not making anything.
So
you're just trying to get to the part where you can start creating.
Yeah. So what I'm going to do is sort of just to round off that point is I have a link here which I'm going to share to you in like Slack or something, and that's it's John Blow over here who's quoting John Carmack, and he's basically talking about this exact same thing, and he's talking about a fly-by-wire flight software which was literally like the entire software was an update method that's like, you know, start and go to start.
Oh yeah, go-tos in C#. Some people have no idea they even exist.
But like the thing was like this was a controller for some spaceship or something, and the entire method, like the program had zero methods, or sorry, it had one method which was like actually not so much update but main.
And I mean, go-to is almost a method in the sense that it's like a sub procedure.
Yeah.
That can be invoked, and kind of control like flow can be redirected to it. Is it just style at that point, or is it? Well,
like I was saying before about over here, where it helps to sort of think about. This is like it helps to think about what is the CPU doing, rather than like what is the language doing. Like if you know if you've got a method call like foo in C#, and then in IL that compiles down to like
call vert. Oh yeah, vert call.
Or,
sorry.
Or if it's hopefully like just a straight up call, if that's like a static method that has no potential for indirection.
Does it become called? Does it become called if you seal the class? I don't remember.
I don't think it does. Like if I ever want specifically a call rather than a virtual call, this one this does two things. It can call through a virtual table. It can also do a null check. So if it's like bar foo, void. If I'm calling like bar dot foo, even if this is non-virtual, it will still emit a virtual call because it checks bar for null.
Has to check that bar is there before you invoke.
Whereas if that's like static, that will issue a call. And it's just a few cycles faster. But the thing is, these all compile down to x86 assembly, which will do something like my x86 assembly is not great, but there's like an instruction called call, I believe, and then there's a whole bunch of like jump instructions like JMP, J and Z, which is jump if not 0. J, E, Z, which is jump if equals to 0. And a whole lot of like jump instructions that just shift the instruction pointer around. Call, this is, I'd have to look this up to actually be sure, but I think call does some stuff with like the stack and saving the stack and saving registers or something. I'm not sure. And there's some cases where a function call like that will issue like a, write, all of the registers that you want to save onto the stack, and then, do the call. And then I think what call does is it saves the instruction pointer to the stack or something. And then, you come back to this method and it's like, restore all the registers that were just saved off before the call. But basically what all of these do is that they move the instruction pointer around.
Whereas goto is just
goto
change the instruction pointer to the where you want it.
Goto is going to be jump.
Straight up.
Just straight up jump. Whereas like while and for, etc. are probably going to be J and Z. And so right before the J and Z, you'll have like C, M, P,
right,
one register.
Because well, that's because you have an exit condition you need to compare against. So
exactly,
there's no way around that.
And so it helps to know what all of these things compile down to loosely. Like obviously, like I was saying, I don't really know exactly what they're going to compile down to.
But we're saying it's not just a style choice. It's like you're choosing between jump and a whole bunch of GUI, where to go.
Yeah.
Registers.
So yeah, if you're doing a jump, then it doesn't have to push stuff onto the stack and then load stuff off the stack and save the instruction pointer and so on. It can just do a straight up jump.
Goto's nowhere in code anywhere except for maybe River City.
Well, I was surprised about how much I ended up using Goto on River City Ransom, because I made a tweet about this months ago, talking about the fact that you couldn't do River City in Java because Java doesn't have Goto and it doesn't have Goto, doesn't have.
There's no jump equivalent.
Struct. I think they're getting struct in a new version or something, but I don't know. And they all of the calls are virtual, which slows things down. And so it's like Java it couldn't have been done. And like the reason we use Goto in a bunch of places is for performance, because it's like, well, I want to get the hell out of this nested search. Like it's a 2/3D game. I'm like for all Y, for all X, and which why we do Y first then X. It's just cache locality thing, and then it's like
crap. I had a different reason.
Oh.
I remember we talked about cache locality a little bit, and then I got it wrong several times, but maybe another night.
Yes.
Cache locality is actually a very, very cool topic that I think we could spend a lot of time on.
Yeah. So, we have a whole lot of loops that look like this, but we've actually got a whole bunch of other cases that are similar to this situation, where it's like, for Y, for X.
Yeah. I mean, I guess, some people would just say, well, you have break already. Why wouldn't you? But you'd have to break twice and have two conditions to get out of the nested loop anyway, right? So it's already.
So you've got to add a variable and check that variable again, and it's a whole lot of other stuff. And then some people will have a method and return and stuff, and it's like, well, I don't want a method because I've got a method because I'm not splitting things out into a bunch of different methods. Like I'm only doing this calculation once, but there's 6 of these loops in a single method because I'm searching for like 6 things.
Mm-hmm.
Yeah.
No, yeah, that makes perfect sense.
So that's the go-to situation. So I think that's everything. What I'm going to do is I'm going to take this link. So this is John Carmack is talking about, do you put the minor functions up the front before the major function? And this is more of a big deal in C where you the order of like.
Oh, right.
The parser in C is rubbish. I can't remember the details because I haven't been programmed in C for so long.
Yeah, it's been a while for me.
And then, do you put the minor functions after the major function? Or do you just stick the minor functions straight in the major function? So exactly what we've been talking about. And so this is John Carmack, and he goes into quite a fair bit of detail about why you might want to do this and like the benefits and so on. So I'm going to copy that link to you. And yeah, that's
cool.
That's basically everything. So yeah, all good?
So next time, we didn't really get into session 2, mostly because I had a break and because we needed to course correct on session 1. So session 2 isn't started yet.
Yep.
For debug overlays, visual test systems, which I'm actually really excited about because I really want to do like a IM GUI type stuff, and that would be a good start. I mean, there's all sorts of interesting questions about how would you make a level editor in the middle of a game, as opposed to using the tools that we have. At River City we have Windows-based tools. The editor sucks was sort of like an ongoing chant and sort of a way to, a morale booster to make fun of the editor. But like, how would you replace it with, like, how would you write a level and the whole transition into the level, and then how would you drag and drop a GIF onto the screen to create animations as they're happening? That's very interesting. And I guess it all starts. I mean, the IM GUI or immediate mode, GUI type of thing is not really related because that's just sort of how you present it on the screen or whatever. But I would like eventually to talk about how to make, I guess we want to call them like editorless engines, because they seem very you think a lot about sort of the leading lights in gaming talk a lot about how we should be removing all of these what do you call it, obstacles to actually getting in there and doing the work, like doing the creating. And so obviously we didn't have time. We had time constraints that would prevent us from doing that in River City. But how do you get there? Like how would you throw out the editor and make a new?
Yes.
Yes, very hard.
I think that'll take a while because that's a fairly big topic, is like an entire editor for a game. But I think you're certainly right on like the structure, and obviously on River City because we had like a WinForms based editor. Like that let us get started.
Rendering line too.
Sorry.
Oh, sorry. It's not important to the conversation, but it also didn't use the game to render the editor on screen, so you ended up like having 2 ways to represent the level. It was how the editor drew it, and then how the game drew it. Obviously, if we could start all over again, we would have had the game rendering the level content.
Yeah, I mean, we did have bits of the game rendering, but yeah, there's a whole lot of functionality that got duplicated, and so that's like one reason why you'd want a editor internal engine, is just like keeping that code, like just reducing the amount of code and keeping it all maintained in the same way.
Mm-hmm.
And that's like a really subtle thing. Like, if I'd known where that was going to end up when I started River City Ransom, like figuring out the engine and stuff, and I mean, I guess there's a whole bunch of reasons we went that way anyway, but I would have put my foot down and be like, no, we're not doing a WinForms editor. Anyway, so I'm gonna stop recording.
Okay.
And so
let me know.
We'll catch all of the people following along on YouTube. We'll catch them hopefully next week.
Oh yeah, the hordes of people that
I don't know
went
how
through
many. I'm
that
going to
building.
look once I stop this. I'm going to look at our viewer numbers and see if anyone's interested.
I'm not sure if even I'm gonna watch this one again. I'll
This was.
try.
I think we went over a bit. All right, and we're done.